Hello and welcome to this lesson on resistance in series and parallel, which is suitable for both GCSE Combined Science and GCSE Separate Science in AQA Physics. So in today's lesson, what we're going to be looking at is resistance in series and parallel, and to be able to apply the laws of resistance in both series and parallel. So if we've been successful and we've learned in today's lesson, we should be able to understand how to calculate the total resistance in a series circuit and understand how to calculate the total resistance in a parallel circuit, which links into the following part of the AQA GCSE specification for both separate science and combined science. That is required practical activity 15, where we will be looking at the combinations of resistors in series and parallel. Now, when designing or analysing circuits, complex combinations of resistors are very common. So to perform calculations, so for example to find a suitable fuse to protect a circuit, it's easier to use a value for the total resistance of the circuit, RT. So RT can be called the total resistance because it's the single resistor that's the total to the complex combination. And we can calculate this total resistance, the overall resistance for both series and parallel circuits. So what we can say is that in a series circuit, the total resistance is equal to the resistance 1 plus resistance 2 plus resistance 3, all the way to the total number of resistors you have in the circuit. Now this makes sense because the more resistors there are in a row, the more collisions there'll be between the charge carriers of the circuit and the metal ions. So therefore, the more resistors in a row, the greater the impedance to the current flow of the circuit, so the greater the total resistance. So what this fundamentally means is that the total resistance of your series circuit is going to be larger than any single resistor. Now, to work out the total resistance of these resistors in series, the resistor values can just be added together. So for example, if we have three resistors in series, a 10 ohm, 20 ohm and 15 ohm, we will add the three resistances together, 10 plus 20 plus 15, to get 45 ohms. So in this particular question, you would just add those resistor values together. So again, here's another example. You've got three resistors in series in a circuit, one of 20 ohms, one of 30 ohms and one of 40 ohms. So we do 20 plus 30 plus 40 and we get 90 ohms. Now a good logic check to make is when you have resistors in a series combination, that the total resistance you work out is larger than any single resistance. Now when resistors are in fact in parallel, we use the following equation, that 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over Rn, where n is the total number of resistors you have in parallel. Now, just to be clear, for your GCSE examination, you do not need to be able to calculate the total resistance in parallel, but you must be aware of the trend of putting resistors in parallel. Now, this equation makes sense because the more resistors you have in parallel, the more possible paths you have for the current to travel and flow down. So therefore, it is actually less likely for the metal ion and the charge carriers to collide, unlike if they were in series, so it makes the resistance lower. So what this equation is telling you is that fundamentally, the total resistance when in parallel is smaller than any single resistor. So when resistors are put in parallel, the overall resistance of the circuit decreases. So an example of the mathematics behind this will be if you had 10 ohms, 20 ohms and 15 ohms of resistors all in parallel with each other, you would do 1 over R total is equal to 1 over 10 plus 1 over 20 plus 1 over 15. You would then find the common denominator in the terms, which is 60, so it will be 6 over 60 plus 3 over 60 plus 4 over 60. At this point, you would have that as a common denominator. You would then add the numerator of each resistor while keeping the denominator the same, so it will be 30 over 60. You would then you can do this by a calculator if you want to as well, and then after that you would flip the numerator and the denominator, so it becomes 60 over 13, which is 4.62 ohms, which again, if we use our logic check, that overall value is smaller than any single individual resistor. So once again, let's have a look at this example. We have 10 ohms, 20 ohms and 40 ohm resistors in parallel with each other. So you would do 1 over R total is equal to 1 over 10 plus 1 over 20 plus 1 over 40. Our common denominator is 40, so it's 4 over 40 plus 2 over 40 plus 1 over 40, which is 7 over 40. We flip that over to become 40 over 7, which is 5.7. So again, in our logic check, the total resistance is smaller than any single resistor present. So just to go over this idea again, using the law of resistors can allow you to determine the overall resistance of complex circuits, as you can see in this particular diagram, and in this particular diagram as well. Now, in a series circuit, we can work out what the total resistance is by doing R total is equal to R1 plus R2 plus R3 all the way to Rn. And fundamentally, what you should be aware of is that the total resistance in series is greater than any individual resistance of a resistor. Now this is because as more resistors are in a row, the greater the impedance to the current flow, so the greater the total resistance. Whilst in parallel, we know that 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3 all the way to plus 1 over Rn. So the total resistance in parallel is lower than any individual resistance of a resistor. Now this is because the more possible paths the current have to travel down, the less likely it is for the metal ion charge carrier collisions, lowering the resistance. So as a summary to today's lesson, we should be able to work out the total resistance of resistors in series and the total resistance of resistors in parallel. So that brings an end to our lesson on the resistance in series and parallel, which is found in both the GCSE Combined Science and GCSE Separate Science modules for GCSE AQA Physics. Thank you so much for listening to today's lesson, and as always, have a lovely day.